Good morning, everyone. Welcome to this Green Future Solutions webinar series organized by Team Norway France. Today's edition is about the synergies between hydrogen and offshore wind. My name is Guillaume Bonnesoeur, and I'm Senior Advisor at Innovation Norway France, and I will be your moderator for this panel. During the presentations, you will have the possibility to ask questions in the chat, and we'll have a Q&A session at the end. Please note that this webinar lasts about 1 hour and is followed by a 1 hour B2B session afterwards. So for this webinar, we have the pleasure to have 5 guest speakers from both French and Norwegian companies. First, we have Eirik Mellaaen, Director of Hydrogen CCS and LNG at Norwegian Energy Partners. Then Bruno Guillet, Project Manager at ADOC, the Occitanie Region Economic Development Agency. Then Ottar Kristiansen, Director of Hydrogen Projects at Aibel. Olivier Job, Development Manager at Lhyfe. And last but not least, Elin Steinsland, CEO at Hydepoint. So before I give the floor to Eirik Mellaaen, just a reminder that this meeting is being recorded. So Eirik, the floor is yours.
Thank you, and good to see you all. So good morning. Thank you for the invitation and the possibility to present Norwegian competence and industry. My agenda is a short introduction of Norway, discuss opportunities and challenges with the combining offshore wind and hydrogen production, inform what Norway could offer to a market, and mention some projects. Let me, if I manage to switch to the next slide. There. I am presenting Norwegian Energy Partner, also called Norway. We are a non-commercial foundation and funded by the Norwegian government and industry. Norway is supporting the internationalization of the Norwegian energy industry as oil and gas, LNG, hydrogen, carbon capture and storage, offshore wind, hydropower and solar. We have more than 300 partners located in 25 markets with local country advisors, and we are part of Team Norway. We have strong stakeholders behind us as different ministries and major Norwegian organizations, as shown on the right side here. I will start with a different concept. Wind power can be used to generate electricity, which can be used for hydrogen production with electrolyzers. Several projects and concepts are combining renewable energy with hydrogen production, as for offshore wind. There are several reasons for that. It's a challenge to transport energy from offshore installation in a cost-efficient way. Wind is an unstable energy source. When it's blowing too much, hydrogen can be produced. When it's not blowing, hydrogen can be used to produce electricity in a fuel cell. Hydrogen could be used as a battery. Offshore wind power has several advantages compared to onshore wind power, including higher wind speed and less conflict with the local population. But it has some challenges, such as high cost for installation, long distance to shore, and maintenance, as well as increased risk for extreme weather. The energy produced by offshore wind could be transported to users as electrons or molecules. And there are several concepts and projects that combine offshore wind and hydrogen production. First, I will give an overview of the different concepts. If you look at the first, here all generated electricity from the offshore wind is transported to shore using subsea cable. Hydrogen is produced onshore. The second, an offshore wind farm with hydrogen production at the central offshore platform. This concept is particularly relevant for a wind farm far from shore. Hydrogen is transported to shore using pipeline. The third, hydrogen is transported to shore using pipelines. Part of the generated electricity is converted to hydrogen here, and the energy is transported to shore using electrical cable and pipeline. So it's a combination here. But also other concepts are possible. It's possible to install one electrolyzer directly on each offshore wind turbine. Hydrogen could also be transported with a ship instead of piping. And it's possible to produce fuel, referred to synthetic fuel, and transport fuel to shore instead of hydrogen. And this is most realistic for production of ammonia. And I have also seen several places that transportation of molecules or hydrogen in pipeline is much cheaper than transporting electrons or electricity in cable. One interesting concept is called Deep Purple from Technip. Deep Purple will use offshore wind energy to produce hydrogen from seawater. Hydrogen will be stored subsea for later use to provide renewable energy on demand. The goal is to replace conventional power production with CO2 emission with a carbon-free solution. Theoretically, such a concept can also serve as an offshore bunkering station for ships, so there are many possibilities. Similar concept was tested in 2004 in the island Utsira in Norway. This was the world's first full-scale project combining wind power and hydrogen production. This slide from NOV shows the complexity of producing green hydrogen offshore. This process includes water desalination, electrolyzers, separation of hydrogen, drying of hydrogen, and storage and loading of hydrogen. And in addition, it's oxygen process that need to be handled. The combination of offshore wind and hydrogen production have technical challenges. The electricity supply is not stable. Power control and conditioning of the power is required upstream with electrolyzers. The electrolyzer must be integrated into the complete system. The capacity of each electrolyzer and the production capacity to cover the future electrolyzer demand need to be scaled up. The electrolyzer is required a large amount of purified water, and offshore this is based on desalination of seawater. And oxygen is a byproduct which could be utilized and transported to shore. Intermediate storage of hydrogen could be another requirement. Subsea and piping infrastructure are demanding, both during installation and maintenance. Development and establishment of standard for hydrogen offshore pipeline is missing, and in general, common standard and regulatory framework of all levels are required. And we must not forget the safety aspect. If you look at the commercial challenges, they are as follows. High capital cost for the construction and installation of offshore wind turbine combined with electrolyzer plant and the subsea infrastructure. We have a price competitiveness, the high cost of renewable electricity compared to natural gas. We have a high cost of hydrogen storage and transportation. We have a limited policy and regulatory mechanism for supporting green hydrogen market development and infrastructure build out. And the country's hydrogen strategy is not covered offshore hydrogen production. And we have a market demand. The demand for hydrogen is uncertain and it takes time to build the market. So timing is therefore important. I will not go into detail here, but only mention that there are several concepts looking at transporting hydrogen with vessel. Transportation of compressed hydrogen is a realistic alternative for short to medium distance and could typically be used there the amount of produced hydrogen is limited. And alternatively is hydrogen in liquid phase, but that's more complex and costly. It's also important to understand the complexity and the dynamic challenges of the electrolyzer process. All energy process will have a dynamic response during startup, operation, shutdown. And typically, Wind varies through the day. That also means that the load on the electrolyzer will vary, and there could be abnormal situation like loss of cooling and loss of water. And it's important to understand the dynamic of the entire system and not only the electrolyzer stack. And this could be done by modeling the system. And there are several projects in Europe and also internationally looking at combining offshore wind and hydrogen production. Aquaventures is one of them, and the vision is to produce 1 million tons of green hydrogen per year and produced from wind energy in the North Sea and transport the hydrogen by pipeline. And some other projects are listed to the right side here. And the value chain for hydrogen with production, transportation and distribution, storage and end users cover lots of Norwegian suppliers with different technologies and competence. I will not go into detail here, but we have companies and we have solutions in Norway to solve such things. And you can contact me if you have any question about companies. And at the end, I would like to introduce you to our database, technology and solution. And here you will find the world-class innovative Norwegian technologies. You can search for companies, technologies, competence, equipment, and you will find matches from more than 1,000 unique value proposition. Okay, that's all. Thank you.
Thank you very much, Eirik, for your presentation. We'll go now to the next one from Bruno Guillet. So, Bruno, the floor is yours.
Okay, thank you. Can you see my screen? Is it okay?
Yes, we can see it.
Okay, perfect. So thank you, Guillaume. Just a few words to introduce myself. I'm based in Toulouse, which is the capital city of that French region in yellow on the map you have on the screen. Next slide. And I work for the Economic Development Agency of the region. We do pretty much the same job as Business France, but at the regional level. And Business France is more or less the counterpart of Innovation Norway. Basically, I'm in charge of invest and trade projects in the field of transportation and renewable energies. So the president of our region, who was elected in 2015, immediately set the ambition to become a positive energy region by 2050. It means that we have to reduce by 2 our consumption of energy and multiply by 3 our production of renewables. To do so, several objectives were given by the president, and among them, let's highlight the development of floating offshore wind energy and hydrogen. The objective for floating offshore wind is to reach 3 gigawatts installed capacity by 2050. And regarding hydrogen, we have a plan with a budget of 150 million euros for the decade to invest in several projects. Regarding hydrogen, the strategy is to develop the uses that will then foster the production. So the regional government is proactive in businesses where they have the possibility to change the rules. They decided, for example, to invest in H2 powered trains and also retrofitted coaches to support H2 track purchase while developing the distribution infrastructure. This is the Corridor H2 Occitanie project. And to replace dredge boats by hybrid ones, because the region is the owner of 3 commercial ports. All those projects will be operational over the next 2 years. The dredge boat will be ready by the end of the year, The hydrogen trains will be in operation next year, and the corridor infrastructure the suppliers were already awarded, and we are now working on the development of production plants. So let's focus now on the floating offshore wind project, so that you can understand the links between hydrogen and floating offshore wind. I would like to focus on the port of Port-la-Nouvelle that you can see here on the map. We want to make it the port of energy transition in the Mediterranean Sea. Indeed, offshore wind in the Mediterranean Sea requires floaters. That's why, if you have a close look at the map, you can see a difference in the different pictograms of the different projects we have in France. And for the Mediterranean Sea, it's only floating offshore wind technology that is going to be used because of the bathymetry of the sea. And in red, you have the pilot farms that will be deployed by 2024. So we have 2 pilot farms in Gruissan and Leucate, just in front of the port. The port, major investments are made in the port to have the infrastructure to build pilot farms and then commercial farms. We are in the process of a tender at the moment for commercial farms. That's why it's in purple on the maps. You have 2 commercial farms that are in the process of being awarded in Occitanie for 250 megawatts. This is the current tender, and the next one of 500 megawatts should be started in 2 years normally. Port-la-Nouvelle is really strategic for the development of that industry. And that's also why we, to develop the ports, we have designed a governance, including a specialist of ports infrastructure and ports development with DEME, the Belgian group in charge of infrastructure, Euroports for operations, and CARE is also involved in the development of the port for the energy part. I will get back to it in 2 slides. Just want to insist on the major investment, 250 million euros invested by the region. Here you can see the huge works that were made over the past 5 years. You have on the left the picture of the port, a sky view in 2018. The work in progress in 2020 with the construction of a dike. You have it on the right, on the pictures of the right of the slide. Now this is finished. The dike was finished last year. 2.5 kilometers of dike to protect this area, and we are building now 2 big moles to support the future production of floating offshore wind turbines and floaters. And to finish with the presentation, the link with hydrogen is immediate. This is in the strategy of the region. We're going to use the production of renewable energy from the floating offshore wind farms to produce hydrogen, and CARE, which is a French company, an energy developer, is in charge of building a plant, a production plant for hydrogen. The name of the project is Hydepoint. The objective is to have a capacity of 50 megawatts of electrolysis by 2030. The production of the plant will start during the second semester of this year and should be operational by the end of 2024. And I put on the picture of the port the location of the plant. So this is really close to the port, where there is enough place to welcome different activities. On the picture, you can see that there is a lot of water on the backyard of the port, and this water is going to be replaced by well, there will be no water anymore in few months to welcome activities. And the hydrogen that will be produced in the plant will be used for many applications, for the maritime river vessels, but also for the dredge boats that will be in charge of cleaning the ports, but also for ground mobility and industry. Ground mobility to provide hydrogen for the hydrogen corridor I mentioned earlier. Well, that's it for the presentation. Thank you.
Thank you very much, Bruno, for this presentation. So now we'll go to the presentation from Aibel. So, Ottar, the floor is yours.
Thank you. Thank you for letting me present Aibel and what we do in offshore wind and hydrogen. So my name is Ottar Kristiansen, and I'm heading the hydrogen development and projects in Aibel. So in my presentation, I'll cover what we are doing in offshore wind and our track record within offshore wind, and what we have done over the last few years in developing the hydrogen business and the projects we've been involved in, both onshore and offshore. As you see on the right-hand side here, we have, based on our background from oil and gas and offshore wind, taken a stake in the hydrogen market, developing small to large hydrogen plants onshore as well as offshore. Our knowledge and experience in the offshore wind, we have decided to develop a offshore hydrogen capability and concepts, taking the wind turbine power, transforming it on a offshore platform, then using seawater and electrolyzer technology and compressors to take the hydrogen produced offshore and transport it onshore in pipelines for storage and offtake to different offtakers, one or more offtakers, depending on what the client needs are. I'll get back to some of the details on this technology and what we've done later in my presentation. So a little bit about Aibel and our role in the energy market. We build and maintain critical infrastructure in the energy industry. We have a long history within oil and gas, and we've taken a strong position in offshore wind, as well as now also entering new markets as part of the energy transition. We are a turnkey EPC supplier for both onshore and offshore energy projects. We see more and more clients also asking us to do the installation and commissioning. And as part of most of the new projects that we're running, we're actually also doing the installation and commissioning, supporting the client, getting the system up and running, and support in the startup phase of the different projects. We have a strong muscle internally when it comes to running large process plant projects, large engineering capabilities in-house, 2,200 people globally. In addition, we have internal yards, meaning that the engineers and projects work closely internally with the construction and yard facilities to optimize the process to efficiently design, build, and deliver these large projects. The yard capacity has a total capacity of 30,000 tons of steel per year. We have engineering offices, several engineering offices here in Norway, covering all disciplines, and also an engineering office in Singapore and a small engineering office in Thailand. And the yards are in Thailand and Norway. Annually, we have a turnover around 12 billion Norwegian kroner. Aibel is coming from oil and gas industry, but we've early taken a role in offshore wind and also in decarbonization of the oil and gas business. So out of this turnover, HVDC, offshore wind and electrification, almost 50% of the turnover is actually now green, meaning that Aibel has come quite far in the transition and becoming a green energy service provider. As I said, the business areas, traditionally we coming from an oil and gas business. We are a leading greenfield and brownfield contractor, developing onshore and offshore projects and infrastructures for the energy companies. Started with that early in the 1970s. In the later years, there's been a high focus on reducing carbon footprint in the oil and gas sector, and Aibel has been involved early on in looking at how to decarbonize the oil production, and we have delivered most of the power from shore electrification of the oil and gas infrastructures in the North Sea. I think we delivered 6 out of the 7 projects so far. Aibel is an innovative company, and the platform on the bottom left side is a process plant for an energy company in the North Sea. It's being developed to be built and delivered now, and it's a fully unmanned process plant. So we're working closely with the clients, developing and improving technology and optimizing the capex and the cost, and as well as the opex. So based on oil and gas knowledge and experience, Aibel was also an early mover into the offshore wind, taking a position as an EPCI service provider. We entered the market already in 2010. We have a solid track record delivering floating wind, as well as together with our partner on the electrical side, the Hitachi, we have developed and delivered several HVDC EPCI projects around the world. Based on this knowledge and energy transition, we see that a lot of what we have on knowledge and experience can also be used in the other part of the energy transition. And we decided in 2020 to enter the hydrogen business, to take an EPC role in this market as well. And this is also where we see a lot of installation commissioning being part of the project offering. We are agnostic when it comes to technology, meaning we can work with a range of technology companies, electrolyzers, compressors, etc., to work closely with the clients to select the different technologies and optimize the technical solution for the client and specific needs of the clients. A little more on the offshore wind projects and services. We are an early mover. We took an early decision to enter this market based on the knowledge that we have. We are a leading supplier of HVDC infrastructure solutions. And today we have a backlog of 15 billion Norwegian kroner to deliver HVDC platforms. We have the Dogger Bank A, B, and C for SSE. Dogger Bank A was just completed at the Haugesund yard here in Norway and is in transit to be installed on the field. And B is on the way to Haugesund to be outfitted, and Dogger Bank C will come later on. And with Ørsted, we have the Hornsea A and B for the UK sector, and we have the Dolwyn 5 coming to Haugesund for outfitting this year for TenneT. So a strong position within the HVDC market. We also entered the floating wind early on. We were pioneers working with Masdar and Equinor, developing the Hywind Scotland floating wind farm in 2017, as well as we are working on future concepts. We are now looking heavily into floating HVDC and HVAC. And on the picture, you see a concept by a Norwegian company, a wind sail. Instead of one turbine, it's several small turbines in the net. So we are involved in a wide range of different technologies and looking at different new concepts. As I said, we decided based on the knowledge from oil and gas and HVDC to enter the hydrogen business. We saw a lot of the knowledge and expertise could be used in this market, developing everything from small hydrogen plants to large hydrogen plants, the gigawatt type of plants, requiring a lot of engineering process capabilities, as well as the construction and capability of actually delivering these type of projects. So on the onshore side, we've been looking at everything from a 20 megawatts plant up to 1 gigawatt, delivering hydrogen to steel, ammonia, e-fuel, entering hydrogen into the grid, as well as a different transportation sector, mainly maritime sector in our case. We, together with Nel, delivered the 20 megawatt hydrogen plant for Iberdrola for fertilizer production. Aibel had the role as engineering and procurement services for Nel, delivering that plant. That's up and running in Spain as we speak. It was delivered last year. On the hydrogen production plants, it's a high focus on technical safety as well as the regulatory. We have all the capabilities to take the role of and responsibility for the balance of plant, and doing system engineering and process design, and delivering control systems, storage, and also buffering system. Working closely with the clients to optimize choosing the right technology and optimize the design for CapEx and not at least also the OpEx of such systems. On the hydrogen offshore, we've been developing different platform solutions in the range of 100 megawatt and upwards to 2 gigawatts. Of course, 2 gigawatt, it's a combination of different sizes and optimizing that for the different wind farms. It's a fully unmanned platform building on what we've done in oil and gas, as well as the unmanned HVDC platform. We are developing a fully unmanned hydrogen offshore solution. And again, high focus on technical and regulatory requirement safety, and developing the full process linked to the HVDC technology and wind farm, as well as large volume storage and offtake management, and optimizing these systems together with the clients when it comes to the CapEx and OpEx. And we're building on the track record that Aibel has on designing and building and delivering technology, and that's the role we will take within hydrogen as well. Thank you. That's all I had.
Thank you very much, Ottar, for this presentation. Very interesting. So now we'll go to Olivier Job for his presentation about Lhyfe.
Good morning, everyone. It's a pleasure to be with you this morning. My name is Olivier and I'm a part of the business development team in Lhyfe. My aim this morning is to give you a few words about Lhyfe, the company, who we are, where we stand, and where we are going in our industry of green hydrogen. First, Lhyfe, who we are. We are a French company. We were settled in 2019, so quite a young company, and with a scope of work which is to be an independent green hydrogen producer. Our headquarters is in Nantes, in the west of France, and we are having a strong growth in the past months and in the past years, meaning that, for instance, we went to the stock market last year and we got from it 118 million euros in order to support our development in a green hydrogen. Our roadmap is quite clear, meaning that we are heading to have in operation 55 megawatts of electrolyzers in 2024. We are heading to 200 megawatts in 2026, and we are expecting to operate 3 gigawatts of electrolysis in 2030. This development will be also balanced because we'll go both on onshore production and offshore production, and we expect that this offshore production could also represent 3 gigawatts in addition to the 3 former gigawatts that I mentioned previously. So you can see it, we have a strong roadmap and strong ambitions, and this goes with the growth of the team that you have part of it on the picture. This picture was taken in the harbor of Saint-Nazaire, of which I'm going to talk a little bit further. And we are about now 180 people in the company. We are settled and we have projects in 12 countries, mainly in Europe, and we have now 6 subsidiaries representing Lhyfe in Europe. So let's tell you a little bit more about what we are doing and what we are currently doing. What you can see here is our first production plant, which is in the west of France, close to Nantes, in the Vendée department. And as you can see it, you have the Atlantic Ocean on at the back of the picture. On the right-hand side, you can see wind turbines, and maybe what you can guess is that we are already experiencing what is offshore hydrogen production, meaning that we are currently pumping seawater in this project, and we are producing hydrogen as far as we get some electricity from the wind turbines. So we are kind of experiencing the start and stop operation of electrolyzers, and that's perfectly what's going to happen when we go offshore. This production plant is currently producing 300 kilograms of green hydrogen per day, and by next year we'll go to 1 ton of hydrogen per day, of green hydrogen per day. What do we do that for? We are doing this in order to decarbonize. We are heading to decarbonize transportation and industry. Okay, those are the 2 legs of our business model, of our mission: decarbonize industry and transportation. And in this region of Vendée, we have a few off-takers, which have mobility players. We have HRS operators. We have industrial operators and companies such as Lidl for their logistic plant. We have also industrial partners, and we are delivering with what I was showing you with that trailers in the picture. We are delivering our clients in an industrial mode with green hydrogen in order to decarbonize their process. So this is what we are doing. This is what we are developing on onshore production for offshore on onshore production, and this is the first step to go offshore, because as you may know, as everybody knows, we have a huge potential for offshore production and to produce hydrogen in offshore conditions. Europe has huge capabilities of production, which are much bigger than the demand of electricity. We have huge coastal areas, so there is a lot of things to do on these areas. It is very relevant that we have the conditions on the sea, in those areas, and we also have the hubs, which will be the strategic sites where the pipelines will go, and when we go for off-takers or where we go for the European backbone or whatever pipelines on hydrogen backbone that will be in a deployment in the next years and 2030 and on. So we have all the conditions and good conditions to foster this development and to be the producer of our own hydrogen here in Europe. So, as I said, we were doing this onshore, and we are currently doing it offshore, and we are experiencing the first floating electrolyzer, which is the picture that you are seeing right now. This floating ship is currently in Saint-Nazaire Harbor. We are finalizing all the commissioning of the electrolyzer in the harbor, and by the end of the spring, this electrolyzer will go to the sea, will go next to Saint-Nazaire or to the island of Le Croisic, where you have these floating wind turbines, which is the only one operating in France so far, and will connect this electrolyzer to the wind turbine, and this will be the first experience in the world of a floating electrolyzer producing in direct connection with a floating wind, a floating offshore wind turbine. This electrolyzer will produce 400 green hydrogen per day, and this means that we are deploying a 1 megawatt electrolyzer in this platform. So this is the next step. Will be and this step will allow us to finish our research and development phase, and we are heading to the industrial mode. And what is the next step? The next step is our HOPE project, which is for which we are currently finalizing the cooperation with the European Union, and this will be our first industrial demonstrator of a 10 megawatt electrolyzer producing offshore in the North Sea on the coast of Belgium. The purpose of this project, as you can read it, is to prove the technical and financial viability of producing renewable hydrogen, transporting it with a pipeline, and to serve our off-takers onshore. And then this is in a very short time, because we are talking about 2025. And from 2025, we'll go for the industrial mode, meaning that we are looking for areas, we are looking for development where we go for 200, 250, 300 megawatts electrolyzers development for the offshore in order to deploy widely this kind of solutions. So that's it for me. I hope this was clear enough, and this will show you that we can do very operational things right now and this is not 10 years ahead of us. It is right now that we can build this hydrogen offshore. Thank you.
Thank you very much, Olivier, for this presentation. So now we'll go to the last one, the presentation by Elin Steinsland about point. So I will just leave you the floor. Elin, yes.
Yeah, thank you very much. Hi, everybody, and thank you for inviting me to this webinar. My name is Elin, and I'm heading up Hydepoint, and I will give you an introduction to the company. So what you see on the slide here is a Hydepoint. It is an offshore hydrogen solution, and we are combining a substation and a hydrogen process plant. This is actually a rendering of a floater that we have designed at the concept level, and what you see is a 60 × 60 meter hull, which is packed with equipment on several decks, with water processing at the bottom, auxiliary equipment such as instrument air, and nitrogen production on the next deck, power electronics, electrolyzers just beneath the top deck. So this is going to be an unmanned solution which can be operated from shore. So this floater is dimensioned to be connected to a 1 gigawatt wind farm. You can see the wind farm in the background here, and have a 500 megawatt electrolyzer on board, which can produce up to 10 tons of hydrogen per hour. So we have integrated all the equipment here needed for both the substation and the hydrogen process plant on board. The design is modular, and it can of course be sized both up and down. And also what you see here is a floater. This is what we believe will be the end game as offshore wind is moving to deeper water. Floating wind is scaling up. But this unit can of course also be realized as a bottom fixed version. So Hydepoint is owned by 3 Norwegian companies. The largest and most well-known outside of Norway is probably Kongsberg. Kongsberg is a leading global technology company with about 12,000 employees working within the maritime sector, as well as within defense and aerospace. It has a long and proud history dating back to 1814. Their main contribution in Hydepoint is their leading technologies within automation, such as control and safety systems, as well as power electronics. Morel is a Norwegian technology and engineering company with roots in the offshore industry dating back to the early 70s, and is providing solutions and services such as engineering, procurement, construction, and integration across the energy value chain. In Hydepoint, Morel is the main engineering hub. Then finally, we have Arendals Fossil Company, a green tech investor company with a long history within the energy market, starting out with hydropower for more than 100 years ago. For Hydepoint, their knowledge in the energy market is key, since Hydepoint in the future can be a player within the energy market. So the companies are quite complementary and cover well many of the technologies and the know-how needed to realize a Hydepoint. So what we will do in Hydepoint is really to help optimize the value of offshore wind farms by combining hydrogen production and energy transmission in a cost-efficient manner. As you all know, intermittence is a challenge already, and with the increasing amount of renewable energy in the total energy mix expected in the future, the need for flexible solutions allowing storage of energy will be very important. And Hydepoint can be integrated with the grid, and it can store the energy as hydrogen, and thereby making sure that all the energy from the wind farm can be used. So the challenge with intermittent power is further illustrated by this slide. For the wind farm developer, the lack of power infrastructure is an issue, combined with the ability to deliver power into the onshore grid. Generally, grids are not dimensioned for the large renewable project pipeline, and it's not going to be possible to scale it to the peaks we will experience with all the renewable energy coming in. So there is a need to store energy, and that's where hydrogen can play an important role. Also, there is a growing need for hydrogen in the industry. Today, there is about 90 million tons of grey hydrogen produced, and this needs to be replaced by green hydrogen. And new segments for hydrogen use will come, such as, for example, hydrogen in steel production. There are two main scenarios for how a Hydepoint can be operated. This is also kind of resembling what Eirik was showing you in the first presentation. So what you see here is first to the left an off-grid solution in an island mode. And in this configuration, the Hydepoint will produce hydrogen out of all the available energy and export the energy by boat or pipe. For larger installations, a pipe connection is of course the best option. When a Hydepoint is connected to a grid in a hybrid mode, there is more flexibility and it can both transmit and receive power, and thereby playing an active role in the energy market, contributing to balancing the overall energy system. When there is excess energy in the grid, power can be imported for hydrogen production and energy storage. The large floater I have shown you on the first slide here will be highly relevant when floating wind is scaling up. Bottom fixed is built large scale now, and this is also where we expect that the first Hydepoint installations will come. And to industrialize the Hydepoint concepts, we have to put together a pilot program. And as you can see here from the roadmap to the right, we are currently developing an onshore pilot to start qualifying the electrolyzer BOP, all the instrumentation, the control systems for offshore unmanned operations, and so on. For the onshore pilot, we are currently discussing using electrolyzer technology from a small Norwegian company called Hystar. We are also planning a 10 megawatt quayside version. It may also be a larger version than a 10 megawatt. And this pilot will be realized as a JIP, where we are inviting wind developers to join us qualifying offshore hydrogen solutions. And this is important because when you want to put a hydrogen process plant offshore, you need to think in a different way than you do onshore. For example, there is another need to think vertically compared to horizontally to be able to keep the footprint as low as possible, since this relates directly to cost. So again, you can see here how we plan to develop this from the first pilots we are currently working on. We are also planning the quayside pilots, and we are having discussions now with Equinor to use their facilities at Kårstø for this pilot, and then we will gradually scale this up according to the market needs. So to be summing up this, a Hydepoint is a combined substation and a hydrogen process plant for offshore use. It will help utilizing all the available energy from offshore wind. It will allow energy storage, and it can supply large volumes of hydrogen that will be needed in the future. So thank you very much.
Thank you very much, Elin, for your presentation. There was one question in the chat, but Eirik Mellaaen from Norway was kind enough to answer it, but I can just mention the question was about expectations or requirements for offshore hydrogen production related to the Norwegian offshore wind tenders, Utsira Nord and Sørlige Nordsjø II. So it seems there's no actually expectation or requirements. The requirements are more connected to maybe the link to offshore oil and gas production. Before we complete this webinar, I would like to remind the Norwegian hydrogen and CCS companies that intend to export to France, that Innovation Norway organized an export program called Global Growth that is starting on the 24th of May. So it's basically a one-year program that includes 2 market visits. If you're interested, it's still possible to register. You can contact my colleague Stephanie Volpi at the Innovation Norway France office. And there's also a link you can see in the chat regarding a webinar on the French market update for hydrogen and CCS on the 27th of April. And you will have more information about this global growth program here as well. So I think there's no more question in the chat, and we almost now 4 minutes from 1 hour. So we'll complete this webinar now. So I hope you found this webinar very interesting. I really find it interesting. Thank you all again for your participation and have a great day. Bye-bye.